Hello, everyone. Paul here to talk a little bit about this Planet Lab. So here it is. There's not too much to it. It's only about 17 questions or so. Not a big deal. But we deal with rotation and revolution and a little bit of Kepler and some stuff like that. So I think it's a useful lab. So we begin with a chart. That is everything that a reasonable person could want to know about the planet. So there they are listed in order. Remember the terrestrial ones are the first four, and the Jovian ones are the last four. Along with the AUs from the sun, I rounded the AUs to 0.4, 0.7, 1.55, 10, 20, 30. There are periods of revolution, so this is how long it takes the planet to go around the sun in Earth days or Earth years. Okay, so these are Earth days and Earth years, not that planet's days. We'll talk a little more about that later on. Um, so how long to go around the sun? Period of rotation is how long it takes it to spin. Okay. Also in Earth days. Okay. Um, and then notice that the Earth is, one, right? And then diameter. Oh, by the way, this is sidereal period of rotation. So this is just literally 360 degrees, not a solar period of rotation. Um, Diameter, how far across? Okay, in miles. Um, Mass relative to the Earth. So how much does the planet quote unquote weigh if the Earth weighed one? So you can see that Jupiter would weigh 317 times what the Earth weighs. Mercury would weigh 0.05 times what the Earth weighs. And then density, right? Mass per unit of volume. And so it's measured in grams per cubic centimeter. Another way of thinking about that is water has a density of 1, right? And so you can see that the terrestrial planets with their rocky bodies and heavy metal interiors are more dense than the I'll get it right, the Jovian planets. And then number of moons, and I went in and updated these are good numbers as of 9/20/2021. And so number of moons, and you can see that um, these hold on, I don't think that one's right. Let me check something real quick, y'all. Yep, as I thought, Saturn was wrong. It's 82. So anyway, number of moons updated as of 5 seconds ago. And yeah, so there's the chart. The first few questions on here are really just going to refer to the chart, and in some cases, all you really need to do is read a number off of the chart. Okay, so don't go memorizing the chart if you're thinking about doing that or something like that. Don't do that. Okay, so looking along here, um, the first thing I ask you about is average density, right? And so what you're going to want to do is take the densities and add them up, and then divide by 4, right? Because there's 4 Jovian and 4 terrestrial planets, right? So add these numbers up, divide by 4. There's the terrestrial planets. Add these numbers up, divide by 4. There's the Jovian planets, right? Do the Jovian planets first, okay? Why are they different? Think about what they're made of, right? And then a little bit about rotation. So if we think about this, rotation is how long it takes a planet to spin, right? And it's also can also be thought of as how long a day is. And once again, these are going to be sidereal, not solar days. Okay. And so, how long is a day on Mercury? Literally, read it off of the chart. Okay. There's no math, nothing fancy. Just read it off of the chart. Okay. How long is a day on Neptune? Once again, read it off the chart. All right. Distance from the sun have anything to do with period of rotation, right? Not revolution, rotation. Okay, you might see a pattern there, but don't look carefully and ask yourself, okay, would the distance from the sun have anything to do really with how fast a planet is spinning, right? Think about that a little bit. Okay, so First 6 questions based on the chart, and in some cases you really are just reading off of the chart. Okay. 7, do Jovian planets have longer or shorter days? Once again, look at the chart. Okay. So, are they spinning slower or faster? Okay. Look at the chart, think a little bit about what you're seeing. Okay. Then, revolution, how long it takes the planet to go around the sun, right? That's a year on that planet. So, how long is the year on Mercury? Literally read it off the chart. Okay. These first few questions, people tend to try to do math, or they try to do something fancy or something like that. It's really not. Just read it off the chart. How long is the year on Neptune? Same thing. Read it off the chart. Okay. Is period of revolution related to distance from the sun? Right. Is how long it takes a planet to go around the sun related to how far it is from the sun? Right. Think about Mr. Kepler. Okay. In fact, we're going to think about Mr. Kepler a little bit ourselves here in just a minute. In fact, let's think about it now. Okay. So Kepler's third law, remember, relates how far a planet is to the sun to how long it takes it to go around the sun. Okay, and that relationship is right here, right? The period squared equals the distance cubed. I'm going to try to circle things. Ooh, cool. Right, that's the relationship right there, right? And so what we're going to do is we're going to plug into that formula. Okay, now what I'm going to do is I'm going to give you D. I'm going to give you the distance, okay? Because that just makes the math a little bit easier. You'll see how here in just a minute. Okay, so if I tell you, okay, a planet sits 2 AUs from the sun, okay, how long does it take it to go around the sun? Okay, well, the formula is p squared equals d cubed. Okay, so we don't know the period, so the period squared equals the distance cubed, right? So ask yourself, okay, what does 2 times 2 times 2 equal, right? So this is 2 times 2 times 2, and that equals 8, right? So p squared equals 8. Okay, so we don't want to know p. We don't want to know p squared, though. We want to know p. So take the square root of both sides. So p equals the square root of 8. So ask yourself, what times itself equals 8, or just hit the square root button on your calculator. And we learned that p equals 2.8, right? And so a planet that sits 2 AUs, that's 2 times the Earth's distance from the sun, will take 2.8 years to go around the sun. Okay, now I kind of did all the algebra steps here, okay, just to kind of show you how to do it. But there might be, and if you want to do it like this, do it like this, not a problem. Okay, there might be a simpler way to think about this, though, maybe, and that is that if p squared equals d cubed, well then p just equals the square. I'm having trouble writing because I'm just not used to doing it like this. But anyway, p just equals the square root of d cubed. So in other words, whatever number I give you, cube it, and then take the square root of it, right? And so 2 times 2 times 2 is 8. Square root of 8 is 2.8, right? Simple enough, okay? If the number is 5, right? If a planet sits 5 AUs from the sun, let's say, right? So 5 times 5 is 5. 25 times 5 is 125. So now what we want is the square root of 125, which equals something I don't know. I'm not going to get my calculator out, but you get the idea, right? And so, I mean, you can go through all the algebra if you want, or cube it and then take the square root of it, right? So here we get 3 times, right? We have a planet here that's sitting 3 AUs from the sun. So take that 3, right? I'll do it over here, right? So take that 3 cube. I'm sorry, I got that wrong, didn't I? Take that 3 and cube it, and then take the square root of that, right? Okay, so that's how you do these, right? 7 is the same thing, right? Cube it, and then take the square root of it. Okay, if we did it the other way, if I gave you the the period, then we'd have to take a cube root, and that's not hard to do with calculators and stuff, but it adds a little bit of difficulty to it. So we're not going to worry about that. We'll just do it one way, right? Where I give you the orbital period, and I ask you to calculate how far it sits from the sun. All right. Okay, so there's that. I give you, I think, two of those. Yeah, two of those to do. Okay, one with 3 and one with 7. Not a problem. Okay, now. If you do have problems, though, let me know. Okay, just shoot me an email and say, hey, I don't think I get that. Let me know. Okay. Okay. Now, I mentioned on the chart that that those periods of revolution are Earth days, right? It takes Mercury 59 Earth days to go around the sun. Okay, it takes, I'm sorry, period of revolution, 88 days, right? So it takes Mercury 88 days to go around the sun. Okay, it takes Neptune 165 years to go around the sun, right? Period of revolution. How long to go around the sun in Earth days or years? Okay, now, but we might want to ask ourselves, if I live on, say, Mercury, how many days in a year on Mercury? Right? In other words, how many Mercury days are there in a Mercury year? Now, once again, this is sidereal, not solar, because we don't even want to go there. Okay. Okay. So figure out how many sidereal days there are in a year on a planet is not difficult. All you need to do is what we see right here. Right? What you want to do is you want to divide the period of revolution by the period of rotation. Simple enough. Okay, so if we look down here, I've got an example. Okay, I say, okay, if the period of revolution of a planet is 455, I can't draw, right? Is 455 Earth days. Man, that's not drawing at all. Yeah, come on, what's wrong? There we go. 455 days, okay? And its period of rotation is 5 Earth days. So in other words, it takes this planet 455 Earth days to go around the sun. It takes it 5 Earth days to spin. So if you're living on that planet, how many of that planet's days are there in one of that planet's years? Well, divide the period of revolution by the period of rotation, right? And so if I do that, I take that 455, I divide it by 5, and I get 91. And so what that means is on that planet, there are 91 days per year, sidereal days per year. Okay, now here's a tiny wrinkle, and that is that if you're going to do this and get it to work, both of these need to be days. Okay, see how I'm dividing days by days here, right? That's how that works. Okay, I cannot divide days by years. So in other words, here, right? If I tell you that a planet has a period of revolution of 50 Earth years and a period of rotation of 3 Earth days, I can't divide years by days, right? It won't work if I divide years by days, right? That's not gonna work. Okay, it's just not. Okay, so what do? Well, it's simple. We just need to turn that years into days, right? And you do that by multiplying by how many days there are in a year, 365.25. So if you do that, and so I set this up and I say, okay, 50 Earth years, right? 50 Earth years. Come on. Oh, I'm pushing the button. 50 Earth years. Okay, there it is right there. Okay, and then I take that number and I multiply it by that 365.25, right? Then I can divide it by that 3, right? So I do that. I say 50 times 365.25 is 18,262.20.25, right? Then I can divide that number by 3 and get my 6,087 and a half over here. Okay, but I needed my marker's not there. We go. But I needed to do that multiplication first, right? If I just divide 50 by 3, I'm going to get a number, but it's going to be the wrong number. Okay, so make sure that when you do this, you're dividing days by days, right? And so I ask, okay, how many days are there in a year on Mercury, right? Look at the chart. Just look at the chart, right? And divide once again. You're going to divide the period of revolution. You're going to divide that by the period of rotation. Okay, so there we go. Okay, same thing for Mars. Okay, same thing for Mars. Okay, Saturn. Okay, I give you the period of revolution in years, right? So Saturn is going to be, yeah, it's going to be the period of revolution divided by the period of rotation. Okay, but it's the period of revolution times 365.25, right? So that now I'm dividing days by days, right? That will give you a number and you'll be good to go. Okay, so in this, for Saturn, multiply that period of revolution by 365.25, then divide by the period of rotation. Okay, why wouldn't this work on Venus? Well, I don't know. Why wouldn't this work on Venus, right? Venus is weird. Venus is weird. Okay. Venus is strange. Okay. Venus will also kill you. Well, they'll all kill you, but Venus will kill you quickly. Okay. Alrighty. There we go. Okay. I'm going to get this up so y'all can do it. And let me know if you have any questions. There's a little bit of math here. I know some of us don't deal well with math. That's fine. If you have questions, let me know and I will be happy to answer them. Okay. Bye-bye, y'all.